if you're here for the Summer Trades Institute webinar with Autodesk and ACE Mentor Program, you're in the right place. So excited to have you. My name is Kellyanne Mahoney. I work on the education team at Autodesk. I'll formally introduce myself in a moment. But before we begin, I just want to let you know what our goals or objectives are for this webinar, in addition to just kind of introducing you to the program itself that we're launching this summer, that we're piloting. So this is an experimental year, and we're just excited that you're going to join us in innovating with us with this program. So like you do with ACE, we hope to also just introduce you to just more ways into the ACE fields, and particularly focusing on the building trades and the way that design and make come together in the built environment, particularly using digital design workflows. And later on, we're going to be talking about how Revit in particular, which is a tool made by Autodesk, supports coordinated MEP system design in collaboration between engineers, contractors, and tradespeople. So again, my name is Kellyanne Mahoney. I actually was a former Boston Public Schools teacher for 13 years. And we're joined by Paulette, who also was a teacher as well. Paulette, do you want to say hi?
Yes, hi everybody. Welcome to the webinar. We're so excited to have you here today. Thank you.
So Paulette is the National Director of Partnerships for ACE. And if you're one of the educators or one of the school champions for ACE, I'm sure you know Paulette. She's famous. And Paulette is going to help us as we are going through the different stages of the webinar. She'll be questions to pop them in the chat if it's a good time. Paulette can interrupt us and ask some questions, but we're also going to save some time at the end for question and answer. So we're going to begin by just talking a little bit about what is the Summer Trades Institute and Externship Initiative. And then I'm going to talk to you just a little bit about what is Autodesk if you're unfamiliar with us. We make the tools that you'll be using in this experience this summer. After that, we're going to hear from my colleague Guillermo, who leads Tinkercad for Autodesk, amongst many other things. And he's going to be talking about designing for the real world. So really kind of going from concept into thinking about placing your design in a real geographic location and how you can use that data to inform your design process. And then finally, we're going to hear from Tyler, who's actually, I'm on the board of ACE Mentor Program in New Hampshire, as well as an employee at Autodesk. And Tyler is my board colleague there. And Tyler Wilson, not Wilson, no one caught that, is going to be talking about Revit and particularly engineering behind the walls. So all of the unsung heroes that we talked about in the chat and the warm-up question, he's going to be really illustrating for us how that all works in real life. So to begin, what is the Summer Trades Institute? Any questions so far, Paulette?
Nope, not yet.
Okay, so the Summer Trades Institute, this is just kind of a high-level overview. So Autodesk has created a sponsorship specially for you for the summer to provide funding to help you get career-connected learning, particularly thinking about how design and construction come together digitally and how it supports work in the skilled trades. So we think this work, we estimate, depending on the pathway that you're taking, that'll be about 30 hours, and you will build foundational Autodesk Revit skills. So that's something that we're going to be talking about today. And hopefully you've had a chance already to do the Learn Revit in 90 Minutes self-directed introductory course. If you haven't yet, don't stress about it. We're going to talk about how you can access that. And this is meant to be an asynchronous learning experience for most of you that are participating. So this learning most of it is going to be self-directed, or if you're in a camp, you'll have guidance from your camp in completing these requirements. So this is the webinar. We also are going to be talking to you about a self-directed Revit MEP training course that you're expected to take after this webinar, after Tyler tells us, a little bit more about how he works in Revit to design MEP systems. And then he's going to introduce to you at the end of this webinar, just on a high level, what the independent work might look like after you take these two self-directed courses. So you should have received a flyer already, and the flyer shows you how you can get started with Revit. So one thing just to make clear is you do not need to purchase any software to take part in this program. It's offered free through the Autodesk Education Plan for students and educators and schools. So on the flyer, these are actually hyperlinked. So it'll show you how you can sign up for Revit. You need to select the student subscription plan, input your school information. It's possible if your URL matches an existing school, you get automatically verified. But if not, you might need to upload either like a report card or school ID. There's some other documentation that they show in order for you to verify that you're a student. And that means that your license will be activated for a full year, and then you can just re-verify again. And then finally, you would download Revit. So these are just the 2 courses. So in a perfect world, you've already done Learn Revit in 90 minutes. If you haven't yet, no big deal. You can do it after this webinar. And then post this webinar, we're going to get into MEP design and engineering. So this is another self-directed course. So Paulette, do you want to speak just a little bit more about this initiative and why we're working together on this?
Yeah, thank you so much, Kellyanne. And we did have a question in the flyer. Someone didn't, or in the flyer, in the chat, someone didn't get the flyer. So I will get that into the chat before this is over. But, as of ACE, our mission is to get, the students excited and enlightened about the construction industry. And with, like Kellyanne said, I work with all of our partners, which Autodesk is one of our big partners. And with this program that we're piloting this in actually 4 different ways. So there are some students doing this, totally on their own. And then we have 3 different kinds of camps going on that's working this into it. And we're going to get feedback from everybody and see what the best way is to move forward. Again, just to reiterate, you do not need to buy any software. That is all being, we have links and providing that for you. And really what we're just trying to do is really just to enlighten our students by connecting technology with the MEP and in the trades. And so I think through this webinar, you're really going to find it very, very exciting. And I'm super excited to see how we move through this program this summer. Thank you, Autodesk, so much for this partnership. We're very excited about it. Back to you.
Right back at you, Paulette. And I love that Excite is part of this mission, and I'm excited about this webinar. So I'm going to keep it moving because we've got a lot of great stuff that we're going to be sharing with you. But just to begin, who is Autodesk? We're a software company. We make software for people who make things. So from bridges to buildings, to cars, to products, furniture. Our customers make a whole world of things, including also graphics for video games, the animation that you see in blockbuster films. So really our work and our mission to kind of inspire the next generation is really fueled by the work of our customers who are really designing and making a better world using our software. So, from greener buildings to, more exciting and inspiring films, to, making products that are accessible for all people. And we find that very inspiring, and we hope that you do too. And we hope that you want to work for our customers someday. So that's part of why we do this and why we offer our software for free for education. One thing to know about our software is it's meant to be across all these different industries that we serve. It's meant to be to kind of provide all the disciplines that work within those industries a single source of truth. So from the top floor to the shop floor, from the design studio to the field, everyone is collaborating and working together and communicating in the same digital file. And in the construction industry, we're often talking about BIM models, so building information models. And you're really going to see that illustrated today, beginning with Guillermo and then moving into Tyler's presentation. So when we think about these phases in the built environment, we think design, plan, build, and operate. When I first looked at this graphic, it confused my mind because I thought, when you plan before you design? But I think that this webinar is actually going to really show you what this means is, when designers are working on a building, as we've already talked about in the warm-up, it's, a building isn't just a shape, it's in a place, and it's also it's a system of things. So there are multiple different designers, different types of designers that are working on the design. And we get into the plan phase, we need to make sure that all those systems work together. So the architectural concept, the electrical, the plumbing, everything, the HVAC systems, that everything is all kind of coordinated so that when we get to the build phase, the tradespeople can actually take that design and make it real. So why are we doing this? Our partnership with ACE, and why are we trying to inspire the next generation of builders? We need to help our customers find workers. One thing to know about the state of the construction industry is the global population is causing us to need more buildings. However, at the same time, the construction, 40% of the current construction workforce is expected to retire by 2030. Many of these workers are also workers that work in the field, who are skilled tradespeople. So we want to make sure that, you know, by 2030, when the world faces a shortage of 85 million skilled workers, that we have inspired the next generation to kind of take that on. So this is a challenge, but it's also an opportunity. And it's opportunity that for you to learn, you know, green skills, sustainability, digital skills, collaboration skills, technology, and to, you know, really to use those skills in order to design and make a better world. You know, in terms of just, you know, we survey our customers. We also work with associated general contractors who provide us with data on the needs of our customers. And 91% believe that that the digital technology skills are essential for firms to adopt in order to save on, you know, in order to address some of these issues that we talked about in the last slide. 59% of companies state that their workforce doesn't have the skills needed to work with BIM, which is what we're going to be learning in this session. And more than 2/3 of construction firms report that candidates lack the skills to qualify for a job. So you're getting the edge on getting a job in the future through learning the skills that you'll be doing through these summer trades institutes. And that's also why we offer our software to students, educators, and schools for free. We want to provide career-connected learning for students, and also to light pathways into the design and make careers that our customers are fueling the future of. So we love to partner with educators in order to support students in this way. So in terms of finding how to get Revit, if you go to the Autodesk Education Community page, and there's a link actually in the notes if you want to post that out, Paulette, you can click on it and you can see, in addition to Revit, there's about 60 of our products that are free. Guillermo is also going to be demonstrating Tinkercad and Forma Site Design today, so you can find them on this page. And what can our students do? What do students do with these tools that they're able to access for free? These are just some results. These are recent projects that we received as part of the Design and Make It Real program that a lot of ACE students participate in. This year's theme was called Make It Heal, and the environment could be part of the healing after something, you know, community changing event, wildfire, flood happened in a community. So you can see all the different ways that students can kind of take an idea and bring it to life. So that's all I have, and I'm excited to pass the mic to Guillermo for him to continue us along this journey from design to make.
Okay, yeah. Thank you very much. So yes, I'm Guillermo. I've been working for Autodesk for a while. I was not born when I started, but that's a different conversation. I got a degree in architecture back in Uruguay. I relocated to the US 20-something years ago, and I was also a teacher at School of Architecture at that time. And yeah, so I'll talk mostly around what we can do for kind of designing for the real world. Is just starting from a conceptual design, and I'm gonna use Tinkercad because it's a simple application. It's kind of the first step for many people. I mean, Tinkercad right now is already 13 years old out there in the market, and with over 120 million people that have used it at some point. And it's pretty awesome what you can do, even though maybe some of you might have seen it in the past and it's like, oh, this is the first thing I did. It's like a toy. Yeah, it's very simple to use. And I'm going to show how to do something there, and then how to take it into Forma Site Design, which is where I would normally start looking into making sure that the building or some of the design intent I have for the building is really consistent with the environment, right? Because that will also help get less air conditioning or better ventilation or better conditions for the building, right? So it's very easy to think about wasting energy on a lot of different systems, but it's very important also to make sure that we treat that responsibly. So I'm going to start sharing my screen and start with Tinkercad. And yeah, the other.
Never
the,
thought before, Guillermo, that Tinkercad is 13 years old, so it's like in middle school now.
yeah, yeah. We're at the stage when we're annoying and
That is true. We do act like middle school sometimes on the
I have a
Tinkercad.
15-year-old daughter, so yeah, I can I have authority on the topic. Anyway, here I am on Tinkercad, super simple. I'm gonna do something very small here and then go to something a little more complex, but just to show how easily you can do some basic conceptual design. So for example, I might be bringing, let's say I might be bringing a box, and anybody can really learn Tinkercad in seconds because I mean you have a box, but also you have little controls that are the same as the ones you have on Google Slides or anything else, except that these are in 3D. So there are also some others that make things get taller or shorter. But let's say that I have something like this, and I'm not caring that much about scale right now. I'll care about scale in a second. But let's say that I'm trying to work on a building and I want to have some sort of open space in the middle and something like this. And now I want to make that a whole, so I will just make a group. So here it is. And I want to have some sort of taller piece here. And I'm gonna make a little sketch, which I will start from here from the bottom. And let's say I want to get something a little taller, a little slanted, so it's much nicer. And now I want to make it not everything curved, but I want to make maybe this one and this one and this one to be curves, so I can then control these points. So okay, that's already looking better. Got it here. I'm gonna make it a little bigger and maybe just slightly overlapped with the building, maybe centered. There we go. And just a little extra detail because I can and it's fast. Just to give it a bit of a sense of scale, I'm going to do something like this, change the color to white, move it up, and then duplicate it here. And I got something that looks a lot like a potential simple conceptual design for building that I want to put somewhere. And then, of course, at that point, does this work well with the shadows from this place and stuff like that? So Tinkercad, simple. You might have done your first project in your life making a name tag on Tinkercad, but you can also do these kind of things. And you can also do more, right? Because the first thing you do always in Tinkercad, or we try to do in Tinkercad, is relate to things that you knew before, right? So that's why I was saying that when you bring a box and if you put it on top view, you kind of already know that this thing is going to make a scale, and if you press shift, it's going to be uniform, right? So we build Tinkercad based on things you know in advance, and putting a solid and a hole and making a hole, that's Minecraft, right? So those things you know them already. You don't have to think about complicated 2D to 3D abstractions, which you will have to do later anyway, right? But it's a sequence. So when we do parametric things, which means that shapes that are ruled by variables, of course, what kind of programming does a kid know? Scratch, right? So we did Scratch blocks, which is basically, well, we call them code blocks, using Scratch blocks. And in this particular case, I'm going to work on a little panel, which I'm going to show here. So this is the panel. It's made based on some code and variables. So for example, just very quickly. So here I'm making a little ring. It's like a flat torus, I would say. It's these parts here. So I define the size, then I repeat it. Horizontal here is the amount of divisions. I repeat it horizontal amount of times, and I repeat it horizontal amount of times, and I move it up, height divided by horizontal. So if I have 4, it divides this thing in 4, and then it just makes the movement so I can go from the bottom to the top with structure. And then I'm going to make some holes with this box here, and then the last thing is I'm going to make this structure, right? And this structure, basically, I will also make it to the height of the panel, and I'm going to copy it along the curve X amount of times, which is vertical separations, right? So I made already my variables, everything is here, and I can also check out how it works. So I have panel height, horizontal divisions, vertical divisions, and if I change vertical divisions to 7 and I play again this thing. There you go. And if I go to more, get it, right? So this is design intent. This is telling me how I want, because probably depending on the instance, on the sign, and even on the angle, maybe I could also add here a rotation block that will also rotate the structure, which is what you have on certain kind of blinds, right? So there's a lot of things that you can do very simple here, and you can also share it or publish it to the 3D to a 3D workspace on Tinkercad. So I could bring it into here, right? So which is what I did. Now this doesn't make a lot of sense in this scale, so I'm gonna use it on a pavilion I already started. But this here is done exactly the same way I did that little very simple conceptual design, right? So this is a sketch, this is another sketch, this is another type of sketch called revolve. So for example, just so you know, if I bring this shape, I can now, for example, if I can make a profile that then will be kind of turn along the axis. So, and you see already how it's going to look like in this little preview, right? So maybe I can keep editing or make it completely curved, or maybe not this part, right? And then finish sketch, and I have this thing that I have no idea what it is in my pavilion, so it's going to go away, but I can do it, right? So, okay, so I have this. I already also made with code blocks, already did this part here in which I was expecting, where I'm expecting to maybe put some plants, right? So again, it breathes, it hits, it looks nice. It also shows the time passing, and now I'm going to bring my panels, right? So if I go here to my creations, I can bring this one. I'm going to rotate it, and again, rotation is as simple as moving. It's just a very simple artifact there that you might know from other applications, again from PowerPoint, for example. I can make sure that it's well connected. There it is. And I'm going to bring another one for the other side. So I made different kinds of panels depending with the curvature facing the structure on one side or the other. Here it is. Okay, so I have this, and now as I'm designing, so I'm going to put it like in a first person view. If I was watching from here, do I want this to be denser? There you go. Because maybe this is south, or maybe there's a lot of sunlight, or maybe because I made a roof with so much overhang, I can do it a little less dense because I want more like views. There you go. And maybe on this side, I want to say, okay, maybe the height of the panel is more like here, like 1 meter, 3 feet. I have to translate into imperial, maybe. Are you proud of me, Kellyanne? I said.
And that could almost keep my dog inside. We wanted to use it.
There you go. Perfect. Something like this, right? So, or maybe now I realize, oh, but I really want the same amount of divisions on this one, so I can change it. But anyway, let's keep it like that. Once I do this, I can now say, okay, how is this going to look in the environment? So I could do send to Forma. I have to send to here, Forma and Fusion. Fusion is our awesome solution, which I also work on for design and manufacturing. So if you're thinking about creating pretty much anything you see around you, I mean, a monitor, a product, a blender, an air fryer, the elevator in which you might be going in up and down, but hopefully with cables, and whatever else, you can do that in Fusion. But then Forma is like the AC, architecture, engineering, construction side of the family. Forma is for site design. In this case, Forma Site Design is for site design, but there's also Forma Building Design, and also Revit, and Tyler is going to show Revit, which is a flavor of Revit for infrastructure. But in this case, if I do send to Forma, I click send to Forma, and it's thinking on the background. And here in Forma, I already have a site already defined, so I can open my site. I think I already sent another option there. Let's see, it's taking a second to open, but here it is. Okay, good. Yeah, I had made a little pavilion there, but I'll take it out. And here is my my little pavilion, right? That came through the export. In this particular case, Kellyanne told me there were going to be people at some point from Cleveland. I said, okay, well, let's do Cleveland. So what do you do in Forma? In Forma, first of all, you have to define where in the earth you are, right? Because location and context is important, right? So in this case, I'm going to have this pavilion very close to the convention center, to the stadium, and to the Rock and Roll Hall of Fame. The reason I used this was because I wanted also to show the wind analysis, and you kind of need something that is challenged by the infrastructure or by the buildings around, right? So a place that's too flat, yeah, the wind is going to be very, very, very simple, right? But once you start having taller buildings, or if I did this, for example, in New York or something like that on the next to the Hudson or something like that, that would be very different, right? Because there's microclimates, there's different things happening in there that change everything a lot. So first thing I do is I bring my pavilion. So I'm gonna put it here. It would be a good idea to maybe to see what's on the terrain, because I've been here in Cleveland, but in a while. Okay, that sounds pretty good. I mean, there seems to be a path here, so I kind of don't want it on the path. I probably want it outside of the path. Last time I did this with Kellyanne in a place in Boston, I ended up putting my pavilion on top of a cemetery, and then I realized it when I put the picture. So I took it out of the cemetery because haunted pavilions are not good.
Poltergeist is not something that we want.
Yeah, I know. I'm more afraid of the living, but still, I mean, I respect everything else just in case. So, for example, you already see a big shadow from what's here. So you can start understanding why you need to understand your environment, right? So with Forma, then you can do, for example, sun analysis, and you run the analysis and see exactly how this is going to be impacting the building, right? So some of the analysis, if I do the very detailed, they'll take too long. So I'm not going to show that when they take long. But for example, there's daylight potential analysis. Well, how many hours of daylight do you have on different parts? For example, if you're doing housing, you need a certain amount of hours of daylight on some specific rooms by regulation, right? You cannot not have that, right? So in the past, as in when I started doing these things, I had to calculate that by hand, right? So I had to do diagrams, sun diagrams, and realize how much of that was happening, which is that tells you a couple of things. One of them is that I'm old. So analysis results, it's gonna take a second, but here it is, right? So I mean, of course, there's less exposure to sun on some of the shorter buildings, but this is kind of what I wanted to see. This is gonna be a problem with this building here at certain hours of the day. So I might, can I move it a little bit? Maybe I can move it a little bit, but for now, I think it's okay. At least I know what I'm dealing with. I'm going to just do one more, which is the wind analysis. So for this, first, I'm going to position the circle of influence of these elements here and maybe make it a little bigger, something like this. And then it's going to do a preview of how the wind looks like in this area. And what do you care about the wind? You care about sort of the comfort, right? Which areas are going to be less comfortable? Like here, sounds like there seems to be something really bad. I'm not sure exactly what's happening here, but it might be an artifact of the simulation. But here, for example, between those two buildings, you have another area. Nothing is terrible, but some things are a little worse than others. Here also, you can see sort of the incidence of the winds and a different orientation. So you can also take that as input to, for example, again, go back here and say, well, maybe I need to make this a little more dense, or maybe I need a solid panel here, or maybe need to open a little more, or maybe the entrance should be on the other side. And all those things, because when you think about how do we design anything, right, is based on context, but also based on the what ifs, right? You can have an idea, and everybody has an idea. We're all creative, awesome, amazing. But the moment you start putting context and putting the environment or whatever is the thing you're doing, you start getting more ideas just based on the inputs you're getting from the environment, right? You can, again, maybe the wind analysis tells you, oh, I need a line of trees here, and based on the line of trees, oh, I also want to build some infrastructure for people to sit down there, and all of a sudden the whole thing changes in a couple of minutes just because of one single idea that could have gone in many different directions, right? So that is why using a collection of tools and thinking of this as more like as a system, right? That is the way things go. I mean, you don't design on the abstract. I mean, you can, but they're not the best ones, right? And remember, this is a place where people will be, right? So how would you like people to live that space? How to experience it, right? So all of those things are part of the design process. And once you're done with all this and you want to build it or want to do the project, you'll need to figure out how does the water run, where's electricity, where panels and all those things. And Tyler will talk about all of that because he has the ability to see inside the walls. I'm looking at it from the outside of the walls. Yeah, that's his superpower. And I'm gonna say the first time I put a pipe on CAD, he was not born yet. So
All right.
there you go.
Sounds good.
With that, if there are any questions, I'll answer on the chat, and I'm gonna stop sharing so you can
And
get.
Glenn, say one more time, Guillermo, where the building was, because Glenn from Cleveland just joined. I think
I can give you the address. It's 100 Lakeside Avenue East. I will tell you the zip code if I put on my glasses because also that's one of the perks of getting over 50. It's 44114. Yeah, it's just the rock and roll for him is here. I can see the shape, and this is the stadium of somebody.
All right, so we're gonna thank you, Guillermo. So taking it from concept to physical location and place, and now we're gonna move on to Tyler, who again has a supernatural ability to see behind the walls and engineer behind them. And he's gonna lead us through what happens once you have to put all those systems together into the building. So Tyler, take it away.
Sounds good. Thank you, Kellyanne and Guillermo. That was awesome. Let me share my screen. All right. So yeah, my name is Tyler Wilson. I am the owner of Integrated Building Engineering. It's my own firm that I started a number of years ago. And a few pictures in here, you'll see I am also renovating an old farmhouse. And with my background knowledge, I've taken on a lot of the actual installation of the systems involved. So not only have I learned just through work on the computer, but also from hands-on stuff, which is giving me a unique perspective that I'll be sharing a little bit with you today. So the things I'm going to cover to give you guys a little bit more of an idea on the career side of things as well is just kind of my story and my path to get to where I am. Then we'll get into the actual MEP systems a little bit. I'll show you how to use Revit a little bit and more so fly around and just show what you can do with it and why it's so powerful. And then in the end, talk about how coordination and teamwork between different trades and disciplines really are what bring a building together. So that's really that plan side that Kellyanne was talking about. So the first part is my story. So I am 28 years old, and I've been designing HVAC and plumbing systems for about 7 years now, I think. But I graduated from college in 2019, 2020 with a degree in mechanical engineering. And now I own my own engineering firm. And it says this week, as awaiting the results of my professional engineering exam, I actually found out this morning and I passed. So part of what I'll discuss a little bit on is how to have your own firm and your path to licensure to actually be legally responsible for seeing how these systems are designed. So I can officially say that I am, which is great. I've been around construction pretty much my whole life. My dad's a general contractor up here in New Hampshire doing small residential additions and garages and decks. So I spent a lot of summers digging holes and pretending I knew how to frame. I didn't really know much back then, but that is kind of what throughout the years here has kept me involved and interested, is because I just have this really long history within the industry, and seeing things get built, no matter how I was looking at it, whether it was construction or general engineering, was always something I enjoyed. So I initially started my company as TRW Design, which was just my initials, where I subcontracted out to other engineering firms in the architecture, engineering, and construction spaces. So I was in a unique spot where my first job was on paper for myself. So I had one client to start, and they helped me a lot and really taught me all that the foundations I know about HVAC and plumbing. My degree definitely helped understand the concepts, but at least at WPI where I went to school, I found there was only a couple of courses offered on the building engineering side. And it was really the principles that I learned there that made it quicker to understand things after. But most of what I learned was on the job. And I know a lot of people that actually didn't even get mechanical engineering degrees that have great careers in the HVAC and plumbing design world. So there's a lot in construction where you don't need to have it all figured out yet. And that's kind of the overarching theme of my story here is that as I kind of grew as my own like non-engineering firm, but still my own company, I started working with a few other engineering firms, taking on projects on, apartments and hospitals and even schools and clean rooms, and just got a really wide understanding of different types of projects and how the whole process between all the disciplines works. And I also, with my dad being a contractor, really focused on how things got built because I just saw that that was a big pain point when I was first starting and was drawing things. Really was kind of drawing that people would get out there and try to build it, and it wasn't really working super well. So that's all led to now focusing on a lot of multifamily and industrial work and sitting for my PE. And I mentioned before, I'd kind of talk about this for your license. You start off, at least in New Hampshire, but it's pretty consistent across the country, by taking a fundamentals of engineering exam. And that you try to take shortly after college, where some places even allow you to take it while you're in school. And that just tells the state or whoever's giving you your license that you know the basics. So it's a broad coverage of physics and like nothing really super specific yet, but really just physics and engineering. And then you need 4 years of work experience under someone who is licensed or a company that is. And then you can sit and take another exam, your professional engineer's exam. And if you pass that, then you're deemed credible enough that you can take on work in the industry and stamp plans, which means they can be built. MEP, it's mechanical, electrical, and plumbing, but it kind of sits where physics meets like the real building and the systems actually keep people comfortable and safe. And I like how even if it's the same building that I'm working on every day, or even if it's the same discipline that I'm working in every day, every building's different, where just a simple rotation, you could take the same building and rotate it and the design could change pretty drastically. So nothing's ever the same. And my advice to you guys as you're starting to figure this out is really just take whatever opportunities you see in front of you that interest you, and don't be afraid to kind of explore and make your own path as you go. There's plenty of work out there in all sorts of different forms, and more than I can even cover just talking to you now. So I wasn't quite sure along my path here whether I'd branch off to a different industry or work with another company or, change things up altogether. But as I kept finding new opportunities, I just kept taking advantage of them and learning as much as I could. And it's led me to have my own business, which is great. So now we're on part 2, getting into the actual mechanical, electrical, and plumbing systems, and then the Revit demo. So when Kellyanne posed the question at the beginning, you guys all were pretty much spot on with where we kind of were hoping you would go with this. So some things that you'd never notice if they were gone. I mean, if you went to fill up your sink and the water, you didn't have the drain pipes underneath and your floor flooded, or, you didn't have the drain pipes that took away waste from the washing machine, or ability to take a shower, or, your pipes froze because you didn't have heat. All of these things happen behind the walls and behind the scenes to keep you comfortable and the building safe. So mechanical is also known as HVAC. It's heating, ventilation, and air conditioning. And that's the air you breathe and the temperature you feel in the room. Electrical, most familiar, I'm sure, with people, but is just how everything, including lights and outlets and appliances, get power and keep running. So yeah, every phone you've charged, every light you've plugged in. You've obviously plugged into an outlet, and that's the electrical systems. And then plumbing is how you get water in and out of the building, as well as how you can actually start heating homes with, in certain areas, gas and propane are used a lot. And those you tend to not really see. You see the end result. You turn a faucet, water comes out. You don't see the sometimes hundreds of feet of pipe that led it to that faucet. And now I have an example of a restaurant that I've been working on that I am in charge of the 3D modeling and partial, it's called coordination, where you make stuff fit. So now I'm going to stop sharing and reshare my Revit model, but I'll be showing you the whole building, kind of highlighting some different things about the HVAC and plumbing systems, and also showing why a 3D model beats a 2D drawing. So, and I actually think logically I'm going to start there because it'll be easiest to show here. So I'm going to stop sharing this screen. And
Tyler, you got a there's a couple of good questions in the chat that we can save for the end, but one of the questions was just about the types of people or clients that you have. I know you sometimes say specifically who they are, but what types of buildings do you work on?
Yeah, so as I'm pulling up the other screen, a lot of my clients right now are developers and mechanical contractors. So kind of a funny split there, but a lot of multi-residential developers in this area where New Hampshire has a housing crisis, I guess, right now, where we're short by something like 90,000 living units, and we're a pretty small state. So there's a lot of construction going up. So a lot of people that either want to build and sell those buildings or that want to build and operate those buildings. I've also done work for a few manufacturers of like turbines and other like industrial type machinery that is made. Those systems get pretty interesting. And yeah, restaurants and office buildings. And yeah, the main four like direct clients would be either a mechanical or plumbing contractor who actually installs the building or installs the systems, an architect in early stage design directly for a developer, or as I did earlier in my career, other engineering firms in which we, collaborate to bring a building to life. And I'm sorry, were there any other questions that I can answer quickly, or should I?
Yeah, we can get to the questions at the end.
Sorry, am I moving on me? So this is a small part of the kitchen of that restaurant that I'm going to show you more in 3D. But this was done originally just in 2D. And this is just the ductwork plans that were given for this project. So as you can kind of tell, there are some things that are just single lines. Everything's black and white. There's text all over the place. And it's just a lot to take in without also seeing all the other things that go into the building. So then we come in and we remodeled everything in Revit, and so that it was in 3D. And this is starting to get closer to what they'll start building off of. So adding elevations and color coding things. And you can see kind of grayed out. We have other pipes and equipment here in the kitchen that now when somebody goes to install it, they just have a little bit more context as to, how these fit together. But so that's one quick win from Revit of just like really easy to color code, really easy to convey information. And it's a lot more clear than just a 2D black and white drawing. And then to the fun part here is this is a restaurant where I just took the roof right off, and we can kind of see all the way in. So everything that's colored is a different system. So as I zoom in here, people have different standards across the country, but I try to keep things consistent for all my projects so that it's easy for somebody else to pick up and understand, where the pink ductwork is always coming back to the equipment. The blue ductwork is always coming from the equipment and cooling and heating the spaces around. Some of the piping, red pipes are hot water, blue pipes are cold water. So I try to keep things pretty basic, and you get the ability to control all of this in Revit really easily, so that if you were trying to draw this all in 2D, you'd have to redraw every single line for every single view. where Revit is really, you're trying to build the building just on the computer. So as much as you can get, every little detail you can add actually helps a lot to figure out if things are going to fit together and work. So it's also a really good tool for talking to clients that and the builders themselves on how things fit together, because something that I've like prided myself on is how much detail we go into to be able to show exactly the dimensions that they need to drop this giant multi-hundred, if not multi-thousand pound piece of equipment onto the building to know that it's not going to fall through the roof. So you wouldn't want to be eating down there and then have this giant piece of equipment fall down. And by using Revit and going into as much detail as we do, we're able to convey that information really cleanly to the structural engineer, who can then pass it off to the welder, who then comes in and reinforces everything below this piece of equipment so it doesn't fall down. So that workflow is a pretty good example of how, one, Revit makes things a whole lot easier to do that, and two, that everything's a collaboration where all these pieces, everyone knows what has to happen, but there are so many specific little details that need to get passed through the chain of people making decisions for it to actually turn out successful. So that's a big takeaway from this. I hope you guys have. I'll just explain it a little later in depth, but just how much of a collaborative process designing and building a building are. And some other cool things in Revit are you can control how much you peel away too. So this is with everything else hidden and stuff grayed out. And everything in here is a mechanical, electrical, or plumbing system. So when you go to the bathroom, you don't see that all of this is actually happening behind the walls. There's so many brackets and so many fittings, water pipes, vent pipes, all these things of a system that I never thought of until I started working, honestly. And it is cool that once you do enough of these projects, you can walk into pretty much any building and get like 70% correct as to what's going on behind the walls. I do, it sounds corny, but sometimes I do feel like I have x-ray vision. My wife hates it. I just walk into a room and just start pointing out things that are wrong. I'm like, oh yeah, no, that should have been over here. Oh, that means this return grill's over here, that the equipment's up here. So you do start to notice some patterns, which gets pretty fun. And some other cool things about Revit are you can also have a bunch of different views for what you are trying to convey, but you can also do section views and look at stuff that, is really tough to see in 2D. And sometimes even 3D, it's tough to see how things relate to each other. But this one view might make the contractor's life a lot easier to install. So Revit gives you the tools to do that and the ability to just help out the guys in the field as much as possible and also convey the most understanding than any other tool that I've used. So yeah, we're excited that you guys will be able to get to play around with it this summer. And this is kind of the culmination of the Tinkercad-to-Forma to then Revit is where you really dial in the final details, document everything correctly, and it's what gets built off of. But Autodesk has done a really good job at providing introductory to intermediate to easily accessible tools to then, be able to have a design mostly conceptually figured out by the time you start messing around with the Revit's a big program. There are a lot of options and a lot of things it can do, but it can be overwhelming to start. So if your design is thought out and planned, coming over here gets a lot easier. So that's the goal with that workflow. And yeah, now does anybody have any questions on Revit itself right now? I do want to hurry up because I am realizing I'm going a little over time here. So I want to make sure I wrap up and get the assignment described. And do you think we're good to keep going?
I think we're good to keep going. I think just one thing that the students should know, but they're learning through the self-directed courses, is that you are using Revit to design architecturally as well. It's just you're getting into more detail than you would, using something like Forma Site Design or Tinkercad. There's also structural for Revit. So there's all different, I know Guillermo said flavors of Revit. So the MEP is one flavor. Now, do you do the fireproofing as well, or is that a different type of engineer that does that?
A lot of fire protection contractors design their own stuff, but what we end up doing is we just model it all anyway, so that we can control like where people are designated to go. So I don't design it, but we have modeled everything the past 6 months or a year, just to make sure that this Revit model that's on the screen has every other trade. Like we have speakers and security cameras and everything in there. So, but fire protection is typically off on its own. So now that brings us to part 3. This one's a quick one, just on coordination and teamwork. So as I was kind of describing, all those things have to come together. And in order for that to work, the HVAC contractor, the plumber, electrician, the fabricator who actually builds the ductwork and piping, construction managers, everybody needs to talk and know where they're going so that people aren't running into each other in the field, wasting time and wasting money. So Revit makes it really easy to coordinate the routing before construction even begins, and just adds a whole lot more clarity so that there's hopefully a lot fewer issues out in the field. So missed a slide there, but that's okay. What I hope you take away is that, yeah, MEP design is a collaborative profession that connects engineering and construction. Digital models help teams work together more effectively, and skilled trades and design professionals rely on one another to deliver successful projects. So thank you guys, and that brings us to what's next. So the next webinar is Thursday, July 9th at 6 p.m. And that's going to be going over the assignment for this Trades Institute for more of the hands-on work that you'll be doing. So I'm going to go over a quick summary there of where basically what's coming up is it's going to be your turn to do it yourself. So we are going to provide you very well-defined guidelines of a project that you're then going to take in Revit and present to a working professional for real critique. So today's just talking about how this is going to go. You don't need to do anything yet. That'll be covered on July 9th.
But they should do the self-directed courses before that.
Thank you, Kellyanne. Thank you. Yeah, definitely do the self-directed courses before July 9th.
They'll help.
Yeah. And to keep you guys having options, but also keep it manageable, we're going to give you guys option A and B, which is either model and document the HVAC systems or the plumbing systems. So each of these will come with a PDF that I'm going to, they call it redlining, but I'll draw in a single line with text and notations what needs to be built for this apartment, and we'll provide you the Revit model to start. And you guys will be responsible for taking that markup and turning it into a real model. We will have as much set up for you as possible, so definitely take the course, learn as much as you can, but don't feel like if you missed a 5-minute segment halfway through that you're gonna, not be able to do it. So we're definitely trying to set you up for success, and also we'll be around to answer questions as you go. So, and step 3 here will be to present it to a professional. That will be sorted out soon, but hopefully somebody working in the HVAC or plumbing contractor space that will be able to tell you by looking at your plans what they would be concerned about, or what looks good, what needs improvement, so that you gain an understanding of how somebody who actually builds it thinks about what you do in Revit, to kind of give you that real world knowledge without having to get you out into the field to try to coordinate you guys actually installing stuff. So it's going to be a cool hybrid way to get field knowledge while working digitally with the tools that we have. And some of the questions that they might be asking is if there's enough ceiling space, did you account for other trades? Is structure in the way? Is it organized? And is it buildable? So that is what I got. So yeah, thank you guys. And yeah, Kellyanne, take it back away.
That was really awesome. I learned so much, Tyler. Just like I've seen this presentation once, and I it's like I feel like I know more dimensions to the way that a building is built. So thank you so much, Tyler. This looks awesome. Also, in terms of questions, I know that one question, Guillermo, if you need to hop, it's okay. If we're over time a little bit, but I know one question was around using Max with Revit. I don't know who wants to take that one? Because it's a tricky one. Guillermo, you want to start?
What's the question in particular?
The question was around using a Mac with Revit.
A Mac computer.
Yes.
Yeah, I mean, Revit is a Windows application. In order to use it in a Mac, you will have to find a way to virtualize Revit, meaning that it has to be on some PC somewhere, and then you can get it into your machine. Back in the day, you could work with parallels and stuff like that, but I'm not sure that still works. But in general, just some sort of virtualization is the only way to, and that's how many studios do it, right? They like the Mac because it looks more fancy, and then they have a bunch of Revits running on PCs remotely, and they connect from there. The experience is not the same because you don't have all the advantages of your own computer, but I don't know. But if you play, if you use Steam or something like that, and for video gaming, you're probably already streaming games, and you know the difference between having a game on your machine or somewhere else. Same here. So, but yeah, but Revit itself only installs on Windows.
Tyler, did you have anything to add to that? I know that we figured it out in East New Hampshire, right? Somehow.
Yeah, there's a way to connect to, if granted, I know school just ended up here. I'm guessing it's the same around the country pretty much, but the students were able to connect to their school server that acted as their Mac or their Windows computer. They were able to access that remotely. But yeah, basically, if there are a lot of people that want that only have a Mac and have no other way to do it, please just bring it up and we'll come up with a more concrete solution to get you guys access in some form or another. But if you have a Mac, it would require basically logging into a virtual computer somewhere, and we can help figure that out for anybody who needs it.
And then there are other specific questions just around how, so there, as Paulette mentioned at the start of the webinar, there are different pathways that you all are taking in this course in terms of, how you're presenting. I believe that Boston and New Hampshire plan to do it in the same way, where there'll be a designated day where you will go into one of the firms in person and present, and that will be organized by your affiliate. Paulette, I don't know if you want to speak to the camp.
Yep. Thank you. There's a lot of excitement in the chat about this, I can see. So each program is very different. So if you're going to the Denver summer camp, it's going to be implemented into the program. And depending on who gets the MEP section, they will probably be doing presentations. We're just not quite sure yet. The same with the LA Trades Camp. If anyone is on here, they're going to be adding a session about this. In Cleveland, they're doing it a little bit differently. So you're going to have to talk with your mentors that are signing you up for this to see how that's actually working for your particular program. We're piloting it in all these different ways to see what actually will work best. Or if offering it in these different ways, it gives more students more access to these Autodesk programs and, the experience with the MEP product with that. So just be, don't worry about it. You will know soon what you are responsible for and your part in all of that. You can always, anyone that's going to the Denver camp, you have my email. We can always follow up as well, but we'll be going over it more once you get to camp. We'll post the things on the Miro board, so check that out. So we don't want Tyler to get, thousands of emails about this just yet. And so check with your mentors first that you have access through this program. And then you can always reach out to me too, and I can get you to the right person.
Yeah, and then similarly for the questions from students around the verification process with Autodesk, please reach out to whoever your affiliate leader is, and they can email me and I can try to help sort it out for you. Because I know that there was at least one other student that I was trying to help through the verification process. So those questions, just reach out to your affiliate leader. If they don't have my email address, Paulette can share it.
Yeah, and like at the camps, they have the computers there, so you won't have to worry about it once you're there. The camps aren't going to they probably won't reach that 30-hour mark like some of the other programs that are doing that. People, some of the students are doing it on their own, and they'll get to that point. But the camps will be probably a little bit less time and set up just a little bit differently.
There's one interesting question for Tyler way back a while back,
Yep.
in which a student was interested. I find it interesting that I, had before I, entered into this world of AEC and design, I didn't realize that, entrepreneurship is also something, like an entrepreneurial mindset is something that you can apply to the AC industry, but also to the building trades as well. And one of the students was asking Tyler specifically, like if you were in high school now, for example, or you're just graduating from high school now, like what advice could you give to a student who's kind of interested in the same career path as you?
Yeah, actually in high school I wasn't sure which direction I wanted to go, whether business or engineering. So I actually took all the business classes I could and all the engineering classes offered at my school. So I ended up leaning more towards engineering. And I think the best thing about it is it teaches you how to think and also identify problems. And in all of business, like that's all you're really trying to do is just solve a problem. And I think for you to, I didn't know where that was going to take me either, but what I did know is that like, I was always thinking about like even like little inventions of just whenever something would be inconvenient to me, I was always thinking like, how could I build a way to be better? Like if I, a lot of my workflows now are people saying that things frustrated them out in the field as a contractor, that I took that and I was like, oh, that's a problem that they were solving on a small scale. I built a process on how we present things to fix it. And so if you're trying to identify problems along the way and try to just get into as many different, like, I don't know, situations or different experiences as you can, because you really don't know where that problem that you're going to see, like, and can actually do something about pops up. So really just, yeah, I really got connected through a family friend to do this. I very well could have gone another engineering route, but I'm glad I did. And you also start noticing some of the parallels between business, any business really. It's all kind of made up of the same things. It's like, what are you selling? How do you implement it? How do you deliver it? And how do you sell it? And luckily, a lot of construction now, it's like really based on how well you perform on a previous job or how nice you are, honestly, and how good of a communicator you are that make you easy to work with. That I haven't really done much advertising and my business is growing. And a lot of that's because of just doing what you say you're going to do and delivering a solution to a problem that they have. And I've just had word of mouth and repeat customers and pick up a few a year. And now it's grown a lot. So yeah, I hope that answers enough of the question. It's a pretty broad, there's a lot to say on it and I could go on forever, but hopefully that answered enough.
Well, you got another great question, Tyler, which is what is the weirdest thing, either business development or mechanical side, that you've encountered?
Like I just had something the other day where sometimes I'll like really think hard about a problem and then like start thinking of how to like design a solution myself, even if it's like a plugin to Revit or something. And then I'll find a feature that I just never knew about that answers that question. That's the only thing coming to mind right now, but I have seen some funny things in buildings that I would have before this just looked over, but like somebody dumping exhaust air from a bathroom that gets really steamy from the shower and stuff, just like into the roof, and there was a bunch of mold everywhere. Of like sometimes you just look at something and think like, what were they thinking? Like, like how did they not realize this was a problem? And if
Yeah,
I think
I have a friend with one of those fancy shower steamers, and I was staying at her house, and it set off the fire alarm in her house from this, and they weren't home, and I didn't know how to fix it. I felt like it was probably in some sort of mechanical issue.
yeah, no, something just doesn't get fully
Yeah.
tightened a little bit, and yeah, few thousand hours later, it's loose enough to go.
Yep.
But after this, I'll answer another one too. But
Weird things. I have a question, which is you mentioned you studied architecture in Europe. How
Oh,
was it? And what are some of the key, I'm not sure if that is true, but what are some of the key differences or similarities you've noticed between working in architecture in the US compared to other places?
actually, I studied in Uruguay in Latin America, but I worked.
thought.
I did work in pretty much everywhere, right? So we had a couple of working in and won a couple of buildings in China. We came second on the Opera of Beijing, and then we did a couple of theaters and airports in China, some stuff in Singapore, a lot of buildings in Dubai, some in Europe too. One of the biggest complexes in India for Tata. So yeah, that's it's definitely different in every place, right? So one of the things that in general, what I saw coming here is just there's a big difference in terms of the cost of construct the cost of the workforce itself, the people. It's cheaper in other countries, so you can take more time and you don't care about that much of the efficiency in that sense. And it's different how you build. I mean, again, time is important, but it's a little less relevant, and you take a little more time on details. Then working a little bit also on Asia, especially in Japan, the precision there is just ridiculous. I remember building in Tokyo in which, okay, let me talk in feet, 800 feet long roof, right? So they had to start with structure on both sides and meet in middle. They met with less than a half a millimeter of error, right? So yeah, and for example, then you realize it because, I mean, of course, everybody works on metric outside of the US, but if you go to work in Japan, for example, the unit you use is millimeters, which is super tiny, right? But it makes sense for the kind of systems they have and the precision they need. If you go to Latin America and many other places, you use meters, in which, again, precision, I mean, you can do like 7.34 meters or 7.345, and then you go to the millimeter, but almost like the choice of units is already saying a little bit more about the precision. I always joke that sometimes it's hard to get a contractor that gets the tiles aligned in the bathroom, and then in Tokyo they were aligning two pieces of structure with less than a millimeter of separation in the span of almost 1,000 feet. So yeah, it's different cultures, different ways to work. I mean, the things have changed a lot here too. Since I come here and also working on software, because I've been working in Autodesk for 20 years and I was the leader for AutoCAD at some point. So I kind of seen a lot of architecture studios or construction companies just visiting customers. And one of the things I've seen the most changing is understanding the building. It's almost as like an assembly, right? Which today it feels like more obvious, just like the system, and also as a database, right? Because everything that Tyler showed and the way I used to show Revit back in the day, it looks like a 3D model, but it's basically a graphical representation of a database. And once you understand that, and once you understand the power of the data behind that, you stop thinking in terms of modeling. You start thinking in terms of modeling with data, which is the reason why we call it building information modeling too, right? So there's been a lot of cultural changes in the way we worked. And I think that in the last 20 years was the biggest one, because I don't see a lot of a difference between working with watercolors in the 1900s and working with AutoCAD at the beginning in 2D. You're still representing. Once you go into the era of data, right, it becomes a completely different game, and those who understand that are the ones that are taking more advantage. I mean, it's been a while already, right? But it's a fundamental change that you need to understand, and you also need to be very aware of what are the new changes that are coming with AI and with other things, because if you just treat the software is just tools, right? But if you need to understand how they operate, so you can be in control and not do what the tool what you can do with the tool as opposed to what you really want to do with the tool. It's fascinating. It's a very nice discipline too, right? Just getting into this world of architecture, construction, and there's a lot of job opportunities too, which is just pretty impressive.
It's a really great question. A follow-up question to that is, how have you seen expectations around sustainability since maybe you were working as an architect, and just kind of how things are changing?
Well, yeah, that's been happening for a while, right? So, I mean, from LEED certification and stuff like that, I would say it's funny in the US on the architectural side, there's been a lot of happening for many years. In manufacturing, we are a little behind. For example, the regulations in Europe are much stricter, for example. And but yeah, in sustainability is relevant for many reasons, right? I mean, you can say it's relevant because it can get you into some tax exemptions, but also buildings are some of the most impactful objects in the world, after cows or even before cows, right? In terms of emissions, buildings are terrible, worse than cars.
Yeah.
Right. And again, the fact that everything can be solved with technology at this point. Makes many people not think about doing it in a more responsible way. But I mean, I've seen changes in there, right? So in tech, in the way actually even it's taught at school. So I think there's hope in that sense
Yep.
that we have
Wait,
a generation that actually cares about it.
they
And
asked the question, Guillermo.
that too.
They care about it. Now, I remember one of the numbers we threw around before that I think is probably still true is the construction industry is responsible for 30% of global waste in the world, which, yeah, it's not great. So, but students, through learning these skills, you're going to be able to make a difference. Another question that a student had was around, can they get Revit certification? Yes, you can. So there is a certification for Revit. The first one that we recommend is Revit Certified User. And oftentimes you can get that through your school if you talk to, whoever the coordinator is, if you have like a work-based learning coordinator at your school or a guidance counselor, oftentimes that can be funded. It's not Autodesk that charges for the certification, it's the testing center that you go to, but oftentimes that can be funded through, the funding that your school district gets. I don't know, Guillermo, if you wanted to add anything to that. I'm trying to see if there's any other questions.
I got two last quick things. If
Yep.
the one funny story that I thought of that was funny was when I was younger, my dad, like I said, was a contractor. He always had other tradespeople around. And so there's this plumber that I grew up just knowing, just this guy, Bruce. And so he watched me grow up. And then, yeah, a few years ago, he ended up being the contractor on a job I was designing. So he actually had to come to me to get approval on stuff. And he knew way more than me, but it was just so funny the fact that, yeah, I'm the one that was determining whether what he installed was up to par. And this guy watched me like from like 6 years old on. And he was like, what the hell is going on here? And then on the waste and sustainability side of things, coordinating with other trades digitally actually reduces waste on the job site. So it's a huge thing that if you design things properly on the computer, it saves a whole lot of material and waste and emissions out in the field. So that's a huge part of like the benefits of doing this is there's the eco-friendly aspect of it, but it also saves money. So both parties should be incentivized to not waste because it saves them money and it helps the environment. And then last part on just like problems to look for of with people retiring at 2030 of like that huge drop off that's going to happen, the entire industry is going to be pretty positioned well to evolve with a younger generation that's looking forward with tools and learning. Like you can learn something that an older person that's in the trades can't learn is the tools that you're being exposed to now and the adaptability to using new technology. So that's a huge pain point that if as you're coming up in your career and even starting out, like if you're focused on the technology part and trying to absorb as much information on the trade side as possible, like you're going to do really great and be an actual asset to a company even at a young age because you'll be able to deal with all of these new things. So definitely keep looking around and what parts of my field have been replaced by AI. You'd actually be surprised. Not much has actually been replaced yet. Slash,
Yes.
like, I also don't know if it will. There are huge tasks that are getting quicker with AI, but you still need to know what you're looking for. And every job is so different. And the construction industry is, I guess, notoriously poorly documented in terms of like what decisions go into every line on the paper, that it's going to take a really, really, really long time for AI to catch up and overtake construction and engineering because there's just so much that is it possible to stay viable if you just choose to avoid AI entirely?
Uh,
I would take my take is no. I think
no, know your enemy.
yeah, the more you're using it, the better, and you'll find
Yeah.
ways to make your work quicker. But yeah, I haven't found any way, not that I'm trying to, but of eliminating any position because all of a sudden this AI is like can just do it all. It's like, no, I built a tool that can set up a Revit project like in like 30% of the time using AI coding. So I built a custom tool, AI using AI. AI is a very small part of it, but now I use that to start up all my projects, and it saves me 4 to 6 hours a project of setup time. So like that's how I'm using it in particular, is trying to like find a workflow that you can optimize with a new tool that I never knew about coding before, but now the tools are there that you can really make anything you want. So the coding
Yeah.
languages are used in Revit. There's a lot of
Doesn't
Python
it doesn't matter anymore. I mean, you use natural language at this point to communicate with Revit on the assistant. So all the applications in Autodesk have going to have an MCP, so that provides context and operates between an LLM and the product. So what Tyler has probably done, which is what anybody can do at this point. So I'm also not a developer, right? So, but I'm making features at this point because I just explain what I want, and then of course AI is going to replace things, but they're going to replace things that nobody wants to do, or that are very trivial too. For example, and it's not even about AI. My first job on an architectural studio in the 90s, it was basically grabbing a bunch of floor plans of a building. I mean, of course, floor plans and just no computers, and counting windows, right? Counting windows in the building because you have to make a table to then buy those things. When you have to count every single window and frame everything from a 10-story building, 20-story building, an hour later you hate life. You get distracted by the path of a fly around you in front of you, and you make mistakes because humans suck at repetitive tasks because we're not good for that. You know what is really good at repetitive tasks? A computer. We are supposed, so we should be good at creativity. We have one thing that AI doesn't have, which is a point of view, right? So we own that. We own that. So if you know what to ask, the way I think AI at this point is like I have 1,000 interns, right? They will make mistakes, but they will get a long way there that I could not do before, right? Just like checking out, I don't know, 2,000 answers from a survey. Before I had to read each of them and start trying to find patterns, put it on a table, all manually, right? Now in 5 minutes, I get that data dissected in 7 different ways. But again, what is important there? Your questions. How do you ask questions to the data? Because you have data, but from data, you need to capture information. And from the information, you get to capture insights. And that's us. That is the human piece of all this, right? So if AI allows you to vibe code something and make a Revit template in half of the time, I mean, you'd better do it. You'll be stupid if you don't do it that way. And you know what? The person next to you will do it. So they will also move faster in the market. So kind of not trying to stay away by not doing anything. It's probably the key to being left behind, right? So I would rather know all these things and then know also where to use it, where not to use it, or at which points you hit the point of diminishing returns. And I saved 80% of time doing this, but now and at some point you're just explaining stuff to the machine. You're like, I don't know, this, do this. It's just like easier to do it yourself. When you get to the point in which it's easy to do it yourself, just do it yourself. But you save hours and hours of the day. Yesterday I was just running 2 agents, doing 2 things I needed. Well, the other part of me, what I was not looking at the agents, was just watching the World Cup because the rest of the world cares about the World Cup.
More simple question, but I think so the question was, are there any Autodesk programs that are Mac accessible? Obviously, Tinkercad is one of them. Tinkercad certification as well, just to let.
Okay, so Autodesk has applications that run on desktops that have to be installed. And then they have also services, right, that just run in a browser. So anything that runs in a browser runs in any machine because it's a browser, right? So you can open it on a phone, on your Mac, on your whatever. In terms of desktop application, and Tinkercad is one of those. It's a service, right? In terms of desktop applications, AutoCAD has a native Mac version, and Maya has a native Mac version. There might be some other from the entertainment side, but the rest is mainly Windows.
But Fusion, you can use.
Yes. So well. Fusion, yes.
On a Mac.
Forget. Yes. So it's Fusion, AutoCAD, Maya, both mostly, and in terms of just the products, right? So for example, Forma, what I showed here is a website, so it doesn't matter. You could be on a Linux machine, on a Windows machine, or a Mac OS, tablet, phone, Raspberry Pi.
Coding language that are used in Revit. Do you know the answer to that?
Yeah, it's the easiest to access is Python with Dynamo, which is their visual coding language. There's just ways to plug in a Python block into that or use a plugin that does Python. And yeah, the follow-up of knowing how to code it, I would say is probably not like the best use of your time unless you want to know foundationally what's going on. Because yeah, right now like Claude and Anthropic, they haven't written like most sectors of that business are being 100% written with AI. So if you don't need to know it, you just really need to know like what you're trying to accomplish really well and like use the AI tool to explore it. And then you can ask it like, oh, how would I go about developing this? What language would it be best? If you say you're designing it for Revit, it'll know to use it in Python. If you're doing something web-based, it'll know to code in a language optimized for web applications. And yeah, this has definitely turned more into an AI thing, so I can keep going on this, but I think yeah, it's pretty cool where it's going and the creativity you're allowed to have now with those tools and how to interact with other software like Revit and Autodesk products and like really any other platform you use in construction, even like Word documents and stuff. They have plugins now with AI that are making things easier. So definitely play around as much as you can and don't be worried as like if you're like don't really know what you're doing yet or like don't really know what you're trying to accomplish. It's like back to the thing of looking for problems. If you're familiar with how to use the tool, you design like build something small to start or like just use it for a small task to start. And then as you get exposure to new experiences, then when a problem arises, you know what tools to use and know where you can go to start exploring. So yeah, you guys have a pretty cool open-ended book here with how things are changing as you guys are entering the workforce. Some people think it's scary, but I think it's pretty cool. You guys are going to have tools that and the abilities that nobody's ever had before you, and it's really going to be cool to see how it shapes the industry.
And so a student asked, how do we as high school students get real life experience in these fields? Well, you're doing it now through this program, through the camps that you're in, through your connections with ACE. I also would say that the project that you're working on that we'll be introducing with Tyler next month, fairly soon in a few weeks, that's something that you could start building your portfolio with as well. And you could possibly use that in order to try to get an internship. I don't know if there are other questions, Paulette, that you see that we should respond to now. I just know it's getting a little late.
Yeah, I think you got them all pretty much. A lot of them were just about the individual programs, and those are still getting fleshed out. So the questions, I can see why there's a lot of questions on that, but I think that's it.
When you're innovating, sometimes things are a little ambiguous.
Yes.
So thank you for
the pilot summer for this. Yeah.
They're pioneers, these students.
Yes, absolutely. And if you just want to maybe talk about the follow-up, and then we will also have that link for that Zoom call sent out. I'll send that out to the leaders as well.
Yeah, and just also to make sure that all the students have that flyer, because the flyer has the links to the 2 self-directed courses, the instructions for how to begin the verification process in order to access the software. So all that stuff, a lot of those questions can be answered through that flyer. But if there's no more questions, I just like the students here are just so engaged. I just always love doing these webinars with ACE because ACE students just have the best questions. I feel like it's because of the great experiences they have throughout the year that are based in real world problems. So this was just really awesome. And we just really want to thank Tyler for coming. And I know Tyler is part of the ACE family as well. We all are. And that, that Tyler put together this great presentation and he's going to continue with the project in July. And thank you, Guillermo, for bringing your world of expertise from moving from architecture and to architecture for software and then architecture using software. So this was just really great. And Paulette, just always a joy to work with you on this.
Right back at you, Kellyanne. This is great. And I do want to say one more thing, Tyler. I loved how you said, hey, take advantage of everything. ACE offers many opportunities in the trades, in pathways, all kinds of different things. Don't be afraid to, like, you don't have to make a final choice. Just be exposed to everything that's offered to you. You have a lot of different, different paths to go down, and just learn as much as possible. Like, don't be afraid to try something. If you're like, I'm not doing that with ACE, just try it. Just try it out. You'll know. So thank you for saying that.
You're already doing great things by just being
Yes.
part of ACE and being part of this. So thank you all. And yep, reach out with questions. You know how to do that. And we will see you possibly in July. So thank you, everyone. Take care.